Well, I suppose it's time to get going.
Well, let me.
Welcome, everybody. This is Richard Clarke. I'm Fred Harland. Lots to talk about. Um, the top news is that maybe we have hope on the pandemic because of immunity to the coronavirus, maybe lasting years, and with recent vaccine news. So maybe it will end someday. And another coronavirus story. We have a third vaccine report, Oxford Astrazeneca, with good results, and it doesn't need to be stored at a lower temperature. In technology on robots, apparently service robots can keep with you even if you're in a crowd. And maybe that's good for grandma to keep her safe. But how about for the surveillance state? And in materials, you can make diamonds. You can make diamonds in your living room. All you need is high pressure, apparently equivalent to 640 African elephants on the tip of a ballet shoe. In flight and astronomy, apparently there are a lot more hyperluminous galaxies, 10 times more that they now can observe than stars apparently can produce. Do we need a new theory to explain this? And on environment, Bezos Earth Fund has given about 800 million bucks to climate groups in their first round of grants. That's nice. In biology, apparently viruses can now control elements of the bacterial gut microbiome. So now, says Richard, it's war. Viruses versus bacteria. On our human brain, something we've often wondered about, maybe you have, I don't know, will it ever be possible to actually share dreams? Some scientists are skeptical. And on health, are high protein diet replacements the key to maintaining healthy weight? So that's what we'll talk about. And so, Richard, to start it off, what's this about COVID-19 ending someday?
Now, let me get the slideshow up. I like to show these anyway. So, the immunity, one of the concerns that people had about coronavirus immunity was they were afraid that it would only last a few months. There were some episodic evidence in the beginning of the pandemic that made people think that. And now they have done the biggest, most comprehensive study of immunity and coronavirus to date. And what they found is encouraging uh, that uh, 8 months after infections, most people who have recovered still have enough immune cells to fend off the virus and prevent illness. The new data shows that there is just a slow rate of decline uh, in the immunity, and this suggests that immunity may last in the body a very long time. What they're hoping is their immunity will be like SARS-2, which has an immunity that lasts as long as 17 years. So if immunity lasts like this and we get the virus, then maybe in a few months or a year or sometime we'll be able to come back to a normal life. And I think this is a big story. That's why I had it first.
Any comments?
We can hope. You never know. Next week, they'll come out with another theory.
Crossing our fingers.
This
Yeah.
one's not a theory. This was based on a study. So at least it's got data behind it rather than somebody's clever idea.
The study also cover if someone were to have a repeated vaccination, like several years after the first one, what would happen?
They don't know yet about the duration of vaccination. They're certainly they're hoping it will be the same. Immunity is immunity and it will last. Particularly what they found was that the long-term immunity, your T cell immunity, persists for many, many years. And they think that's hopeful with coronavirus because the coronavirus doesn't hit you all at once. It takes a period of several days after you're exposed before you start having the effects of the disease. And that's long enough, they think, for your T cells to turn on and start killing the virus.
Yeah.
So
So
anyway,
the people that we heard of who had gotten the virus and then got it a second time, those were isolated cases and there was no study done?
there are not enough of them to study them carefully. They are just episodic evidence. What I'm still concerned about and what they don't know about is these viruses mutate and mutate pretty fast. And who knows if the next version of the virus will be caught by the different vaccines and immunity. An example of a virus mutating fast is the flu virus that you have to get a different shot for every year because the virus strains mutate and are different.
Also, it's possible that they can roll the coronavirus. Some of the flu viruses are coronaviruses, and it's possible that they can roll the new vaccine into the regular flu vaccine in a year or two, where you would get that extra boost every year along with the flu vaccine.
Maybe. Now, also, one of the things about the 3 vaccines that are out already is they're all based on, the coronavirus, all the pictures of the coronavirus, they have all of these spiky things sticking out. And all of the vaccines are based on attacking that spike. And that spike is such a big part of the vaccine that they don't think it'll go away because of mutations.
And apparently the third vaccine reports have very good results and don't have to be stored at low temperatures. Is that the one we just did?
That's the one that we're talking about here, the Oxford Astrazeneca vaccine. And while this one is based upon RNA, it's not done like the other 2 vaccines where the RNA is used for the vaccination. Here, they do something with some other host. So they put their genetic thing in some other critter and then harvest what comes from that. And so the vaccine is made in a more conventional way. And that's why it can be stored longer. And it also turns out that this third vaccine is going to be a lot cheaper. It will be maybe a tenth of the cost of the other 2, mRNA vaccines. So
Moving
this will come
forward,
out of, it will probably go into production in December.
moving on to technology, if you have a service robot, apparently now it can keep up with you, even in a crowd, it'll see you. And that's good for keeping track of people. But is this the beginning of the surveillance state? What's that about?
Well, we already have the surveillance state, but it's just a new, it maybe is a new tool. It's interesting how they have developed these things. This started with a group that was working with assisted living homes and places that work with elders. And what they had were trying to do is to see what they could do to make their service robots more useful. And when they surveyed all of these places, they said it would be great if they had a few important skills in this robot, which includes escorting a resident to the dining hall or following a staff member to the next location where it's needed. Or how about playing a game of tag with the residents to encourage them to get out of their chair and exercise? All of those skills require the robot to be able to identify a person and then follow them around. With the AI technology that exists now, they have face recognition tools so they can identify people. There also are other routines which they call anonymous person tracking, which can follow a person around. So what they did was combine those two techniques into a more advanced algorithm. And there, what they have is a system that can cope with occlusions. That's when a person is behind an object. They can still keep track of them. Uh, they can also deal with poor lighting, and they can also deal with what they call temporary lost target recovery. I can't see them and now I can. Okay. And it turns out, again, these uh, robots will be very useful for doing things that are, people need, and giving them the kind of assistance and support they need. They are trying to work further on them so that they can understand social gestures, and they can do things like routine room inspections and carry out conversations with the old people, and then provide entertainment besides playing tag. So this is the kind of thing that they are trying to do now with these robots that they're using, particularly with old people. I just added the comment about the surveillance state because I'm still a little suspicious about computerized identification and tracking systems. So that was not in the article. I just put it in my suspicious comment.
Yeah, you're a Republican at heart.
I don't think so.
But that's their theory.
Now, when I was about 12, I went back from, and we had moved to California. I went back to visit my Oklahoma grandfather, who was a FDR Democrat. And I told him, because I knew it would get his goat, that when we went to California, we'd become Republicans.
So what are the physical characteristics of this robot?
This particular robot is only about 18 inches high and is on wheels and drives around and can carry things. It doesn't have hands yet, but once they develop this skill, then the rest of what it looks like is really packaging.
Yeah, right.
One thought that occurs to me, Richard, is why don't they use dogs? Dogs can be trained to do a lot of things.
That's right. They never thought of that.
Probably less
I guess.
expensive.
Now, the problem with dogs, I'm not sure how you're going to have the dogs holding conversations or checking the people's room.
Well, can any of these robots do all of the above? Dogs can't do everything, but can robots?
They can do some of it, and they're working on the other parts. They can already follow people around and escort them to meals and play tag.
What are the functionalities we should request is that they can walk on cobblestones?
Yeah, exactly. Go upstairs.
The
They can't go upstairs.
the Mexa robot.
A lot of people don't want to have anyone answer. They just want to. They can pretend he's listening.
Certainly, you said something about stairs. Did you, Phyllis? That's got to be a problem for these robots because they have wheels.
Yeah, exactly.
We're going to need another model.
Maybe it'd be more economical to cluster some of those activities in a dog.
Potholes are going to be a challenge as well.
This is just a part of what they are doing around the world with robots, trying to figure out ways where they can use them effectively to provide support for old people.
Oh.
And certainly they use dogs with old people, but
there are a lot more.
There are some things that dogs can't do.
Pathetic.
Moving on to materials, apparently you can make diamonds in your living room. All you need is high pressure, equivalent to 640 African elephants on the tip of a ballet tuna.
That's all.
So
right.
That may be more pressure than you have in your living room, but before this experiment and before this work, what they knew about diamonds is that diamonds were formed in two ways. The most common way is deep in the earth under high pressure at more than 1,000 degrees centigrade, and they think it takes 1 million years or something. And the other way you can make diamonds is it turns out when comets hit the earth and make an impact of the earth, there is a kind of diamond with a different crystalline structure that forms after the asteroid's impact. So it turns out that they are able to make both of these kinds of diamonds, and they just have to apply enormous pressure. They can do it at room temperature, so you don't have to have the high degree. There's one other trick, though, that they do, and that's besides the very high pressure, they do something that is allowing the carbon to shear. This is kind of a twisting motion, and they think that this shear, this moving around of the physical things, then allows the carbon atoms to move into place and form these two kinds of diamonds. And they said upon the first time they were successful seeing these little rivers of diamonds for the first time was just amazing. And so they're like streaks of diamonds in this material, and around it are the what are called the long Dalet diamonds, which are the diamonds formed by the meteor impact. And within that streak of the meteor diamonds in the center of it, then they're the kind of diamonds that you might put on your engagement ring. So I don't know what this
Any
is.
comment?
Well, I would like to, well, I wonder how they compare to so-called industrial diamonds.
The kind of diamonds that they make that are like from the comet, those are almost 50% harder than the regular diamonds, and they're harder than most industrial diamonds. And it was really those kind of diamonds that they were trying to make, because there is a very high demand for those as cutting and abrasion. So what they were trying to make was industrial diamonds, and really kind of heavy duty industrial diamonds. And they got as an accidental byproduct the kind of diamonds that you would put on a ring.
All right.
Apparently, in terms of astronomy, there are some very luminous galaxies. The problem is that there are 10 times more of them than stars can produce. So do we need a new theory to explain it? Why are there so many hyperluminous galaxies?
Well, they are wondering about this, I have to say. And the background story is that in the beginning of time, in the early galaxy, there was a lot of gas and matter around. And in the early galaxy, there was so much stuff around that they were able to make early galaxies that were massive, hyperluminous galaxies that had the brightness of 10 trillion suns, which is pretty bright. And there's not as many of them now because the gas got depleted as the universe spread out. It didn't get depleted, it just got spread out. And then recently, astronomers were looking at using the infrared space telescope Herschel, and they found a lot of these ultra-luminous infrared galaxies, but what they found was 10 times more than expected per theory. And when in science, when reality doesn't fit your theory, it means it's time to change the theory. And they basically don't have any idea what's wrong with this, but having your theory off when you check it against reality, having it off by a factor of 10, an order of magnitude, means you really got work to do on your theory. Now, some people have said that maybe this is connected to the fact that, we don't know what most of the matter is in the universe and stuff like this. So there's a lot of the theory of physics and space that, we're still working on.
Comments?
Well, nobody reacts to us being off by.
Well,
Okay.
That give us a little time. Where does this illumination come from, I wonder? Do they have like multiple sounds within clusters or something?
Again, they just don't know.
But everybody does.
Now, one of the things that still, for me, is interesting about the work that they are doing with the physics that they're trying to understand the universe is that it still shows that there is so much that we do not know. And for me, that's still exciting. That's why we.
Yeah.
The other thing I like about science is that you change your theory when it doesn't fit reality, which is the opposite of politics, where it doesn't matter what the reality is, you can take a political position.
That's right. Yes. Now, that's why some of the politicians have had trouble with science.
Okay, moving on to environment. Apparently, Bezos and his fund has given about $800 million to climate groups in the first round. Can you tell us a bit about that?
Well, the first thing about this is that this is done by a fund. Let me get the name of it. The Bezos Earth Fund. The Bezos Earth Fund was not started until January of this year. And having them give $800 million in their first round is kind of impressive. It also is interesting with most of these funds, there's a large organization, a website, and published criteria and stuff like this. There's none of that for the Bezos Earth Fund. There's no staff. There's no website. There's no published releases about what they're looking for. This just happened. The Bezos ferry came and just dropped $800 million on these different organizations. They did talk to them first, so it wasn't as an entire shock. And Bezos, apparently, the way the decision was making is that Bezos was really in charge of it. And he says, quote, "I've spent the last several months learning from a group of incredibly smart people who's made it their life's work to fight climate change and its impact on communities around the world." And so the reason there's no big committees or something like that is Bezos is doing the work and having his people do follow-up and stuff like that, but he's the guy who's making the decisions. It's his money and he can do it however he wants. And here, let's hear what he did. There's first a big group of big name environmental nonprofits, the Nature Conservatory, the Natural Resources Defense Council, the Environmental Defense Fund, World Resource Institute, and World Wildlife Fund. He gave each of those $100 million, which is and then there are several organizations that are pass-through organizations that make grants to smaller organizations working against climate change. And these include the Climate Works Foundation, the Solutions Project, and the Hive Fund for Climate and Gender Justice. Each of these got $43 million. Then there's third group of people who are pushing for scientific and technological advancement to promote job growth in the so-called green economy. One is the Salk Institute for Biological Studies, got $30 million to advance its research in the ability of plants like corn and soybeans to pull carbon out of the atmosphere. The same son went to the Energy Foundation to support their advocacy about electric vehicles and zero emissions buildings. Then there's another group, the Union of Concerned Scientists, got $15 million to advocate for electric trucks in to update the U.S. electrical grid. And the Rocky Mountain Institute campaign for carbon-free buildings got $8 million, with another $2 million going to one of their startups called the Dream Corps for Green for All. And then there are a couple of other organizations, the Eden Reforestation Project, which restores ecosystems in developing countries. They got $5 million. And there's a native-led group, the NDN Collective, that got $12 million. Nobody knows what they do, but they got $12 million to do it. And so this is just the first round of Bezos making these kind of grants to organizations working with climate change. We assume that next year he's going to give another 800 million or $1 billion to yet another set of groups. And, this seems to me to be remarkably good work for somebody with money, and he's actually doing something to help us. So thank you, Bezos.
Mhm.
Any
That's a
comment?
lot. That's a lot of money.
Yes.
I mean, for any of these non-for-profits, I mean, maybe you think they get too many people like giving them $1 million? Forget about $43 million.
That's or $100 million or even $8 million.
I hope he's making good decisions.
Uh-huh.
Yeah.
Well, he's done okay so far.
There's another billionaire that is giving Mike Bloomberg,
Yes.
has been giving a lot to support environmental studies, and he paid United States membership in the Paris Agreement. He said, I'm going to pay at least for the membership after we got out of it. So there's a lot of people with a lot of money doing some good things.
Yeah, excellent. Excellent.
Bezos is an unusual businessman. I used to live in Washington, D.C. I lived there for over 15 years. And not far from where I lived, he's almost finished building a $29 million mansion with a ballroom. And it's not to flaunt his wealth, but to invite intellectuals, philosophers, writers, poets, scientists, and world-class people to come and meet with him and share their ideas. So he's a very intellectual and eclectic guy. He's not just obsessed with money like some businessmen tend to be.
Uh-huh.
He has a very wide-ranging interests and a very unusual kind of guy.
Uh-huh. That's the case with some of these people in technology is, besides the technology, they have broad intellect.
Right. Bill Gates like that too.
Yes, and one of the things that contributes to the good intellect is this kind of broad thinking means that you're going to come up with more creative solutions often than people who have a more narrow approach do. And I think Bezos has done that here. It's an amazingly varied group.
Good. You know what? I don't remember the details of the article, but did they have to give some goals? Did they send proposals in?
No,
Whoa,
no.
imagine getting that letter in the mail. Oh,
That's right. That's right.
Jeffy Bezos. Woo.
Are these mostly United States companies, or other than the reforestation program? Are they around the world or just in the United
They're
States?
around the world.
Okay. Good.
Well, moving on to biology. What's this about this war between viruses and bacteria?
Oh, yeah.
Well, it turns out it's an old war. It's been going on for a long time. And what this is about specifically is that in the interest here is that they have discovered how the most common virus in the human gut infects and takes over bacterial cells. And this finding, they think, can be used to control the composition of the gut microbiome. And so this war between the viruses and bacteria has been going on for a long time. And there's a class of viruses which are phages, which attacks bacteria. And there's a kind of phage that's CRASS phage, and they are the most abundant viruses that attack bacteria in the human gut. And they believe that these viruses actually control our intestinal community of microbes. And that understanding how these viruses infect bacteria may allow scientists to control and manipulate the makeup of the microbiome, either by increasing the good bacteria or decreasing the bad bacteria, and using viruses to do all of this stuff. And so this is a new kind of tool that will show up in medicine, and it seems to me to be kind of funny that we're using one kind of microscopic bug to go after the other kind of microscopic bug. I just hope it's not like the rabbits they put in Australia.
Oh, yeah.
Any thoughts?
Yeah, I think it might be helpful. If I'm repeating myself, please stop me. But to differentiate between bacteria and viruses, bacteria are true living creatures. By definition, they can reproduce by themselves. Viruses are not really living creatures. They're little strands of DNA that need the living cells of another animal or human or a bacteria or bird or whatever to reproduce, because they basically
they use the DNA of the eukaryotes to be able to reproduce.
They can't reproduce by themselves.
And so they don't do it themselves. It also turns out, as I've been doing this science reading in the last several years, I didn't know much about biology to begin with. And it turns out that because of the way the viruses change the DNA of living cells, that they think that the viruses actually played a big part in the development and evolution of life, because through these viruses, the cells are able to make other kind of changes that they couldn't make without this outside interference.
Right.
So the picture is really fascinating. And,
Yes.
we're at the stage now where we're starting to understand some of the details.
The other thing too, I read somewhere, it was very interesting that the human body, every single human body has tens of thousands or maybe even hundreds of thousands of viruses and bacteria at any given time.
More,
And they're all unique to that human being. And actually one scientist was trying to determine whether like fingerprints, you can uniquely identify each person. He developed a hermetically sealed unit and he would put people inside and everyone had a different viral and bacterial signature.
yes.
And we need all these bacteria and viruses to be even alive.
Yes. Now, bacteria, there are something like 10 times as many bacterial cells in our body as there are human cells. So not only are they in there, but they outnumber us. And it turns out there's more viruses than there are bacteria.
Hmm.
So anyway, it's an interesting environment that we live in. And, one of the things that they are learning about life is how much of life is symbiotic or depends upon other species to be able to live and thrive. Fred made a comment in his UU statement about biological diversity, where this diversity is what really is required for any species to survive and to thrive, because we need all of these other things and we depend upon these other species for our life. And if you look at it with the viruses and the bacteria, we depend more deeply than we realize. And so we're not just separate human beings. We are there with our symbiotic relationships with all of these bacteria and viruses. They need us to live, and we need them to live.
Any thought?
Well,
Doesn't sound
mentioning the
very
different
comforting.
combination of, sorry, different combination of bacteria in each human being reminds me of the analogy of the elm tree. They were all destroyed because they were all the same. They were all clustered together. You have to have a variety in order to survive.
Mm-hmm. Requisite variety is the expression, I think.
Yeah, whatever. Yeah. Sorry.
We're waiting for you, Margot. We know you have something to say.
Oh, it's not very comforting knowing that those viruses and bacteria are inside of you, even though they need them. I don't know how many people sleep well at night knowing that.
Well, it's not.
Maybe they're.
I would clarify, it's not only inside your body, but outside your body as well. There are viruses in your hair, on your skin, in your elbow joint. And basically, apparently, if you obsess too much about cleanliness and start wiping them off with disinfectant, you develop all kinds of skin infections.
Yeah.
These bacteria is what keep you healthy.
Yeah.
Yes.
So it's a spooky thought.
So moving along to us. Will it ever be possible to share dreams? Why are scientists so skeptical about that?
Well, the first part of it is, in these the science fiction and things like that I've been reading for more than 50 years, then dream sharing has been a regular part of these stories, and they are so much so that here the editors at Gizmodo went around and asked a number of experts where we are on the ability to record and play back dreams. And it's kind of interesting listening to the experts. Here's Susanna Martinez Gandhi. So she's a professor of a lot of things: ophthalmology, neurology and physiology, and pharmacology. I don't know how you get to be a professor in all of those things. Maybe Fred can tell us, but uh, and she says there's no theoretical barrier to the possibility of accessing the content of someone's dream and reading it out and recording it and playing it back in somebody else. But you know, the uh, and that the circuits in the brain that it uses in dreaming are no different than waking life. So she says that part of it is looks like it's easy, but the big caveat that she has is we still don't know the neural code and we have no idea how conscious experience is encoded in the brain. And it doesn't matter how fast technology is, if we don't understand the underlying neurophysics, then we can't really decode brain experiences. So she's saying maybe we can do it, but there's a lot of stuff we don't know, is her take on it. Here's Robert Strickgold. He's a professor of psychiatry at Harvard whose research focuses on sleep. And he says he thinks the answer, at least for the lifetime of everyone who is listening today, is nah, not a chance. And he says the best they've been able to do so far with fully awake individuals is put them on an fMRI scanner and figure out whether they're looking at a face or a tool. And so he says they can read this stuff, but they can't tell much of what it is yet. And then Adam Horowitz, who's a research assistant at MIT Media Lab who focuses on brain science, he says, like so much of science, the question is a door to more doors. To share dreams, we have to first define them, draw some kind of boundary around the dream. And for example, is it the visuals that define a dream? Is it sight that we want to share? And uh, he says the problem with dreams is that dreams are an amalgam of memory. They're internal explorations of your own personal network of meanings, and they have stuff embedded in them in personal context. And so the same sensory experience in two different minds may be an entirely different experience. And so if this is the case, how are we going to record dreams and play them back in somebody else? And he says we cannot share a whole dream without sharing the whole self, because the dream occurs in the context of the individual. So he's not very encouraging. Here, R.A. Davis, who's a research associate in philosophy at the University of York, and here's another T.W. Stoneham, who's also a professor of philosophy. And they say this has two interesting aspects. One is dream sharing, to have other people have the same dream. This is called, they call it co-dreaming. And this is actually something that shows up in some African cultures and was there in Mesopotamia, Egypt, and Greece, and where you can have one person, they think, dream for another person or relate messages from one party to another party in dreams. So this is co-dreaming is one part, and then the other kind of dreaming is dream scanning, which is what most of the people are talking about. And uh, he says they think dream scanning wouldn't reveal much because the information we gain from scanning the brains of sleeping people, uh, because the what people report dreaming is influenced by so many other factors like culture and social expectations. So they think that this dream sharing or dream scanning may not be very possible. They say, though, he thinks there is hope for dream sharing, and there where we can have different people dream a similar dream at the same time. Maybe then they'd all wake up and talk about their version of the dream. So all of these guys are saying maybe we'll have dream sharing someday, but they think it's a long way off. So regardless of the science fiction stories that I've read for all these years, it looks like it's still kind of, we haven't worked it out yet.
Any thoughts?
My first thought is they could be working on something more important.
And my thought is, I wish they'd work on having you remember your dreams.
Oh,
That's the hardest part.
yeah.
Well, if they could record
Some
them, then they could play them back when you're awake.
But dreams often are nonsensical, that there's not a thread through the dream. You're in one situation and all of a sudden you're in a completely different situation.
Yeah.
So I think it has to do with our own psyche and our
Yes,
experience, what we have seen. But
Mhm.
I know most dreams I forget, but a few dreams I'll remember for a while.
I think they're unique to the person, and I don't see how anyone else could experience
Definitely,
the same
yeah.
dream.
Certainly,
Just
that's what
different
some of these
people.
scientists are saying is that there's so much personal context
Mhm.
involved in the dream that even if you play the dream for somebody else, they wouldn't get it. Now,
Yeah, I
one
think
of the
it de-
science fiction themes that I read about was recording somebody's dreams and playing them back. So then there's a market in the recording. And so then you get to have stars of dreaming who become famous for their dream. And that then these dreams, then you would find all of this subtle sexual symbolism where you have the hills in the background that look like women's breasts and things like that. And so that's what it took to become a dream star.
So Richard, what does recording of the dream look like?
Well, that's what one of the guys was saying, that is the dream the visual sensation? And if it is, they think maybe they can get that.
But how would they record it? I mean, it's like a video. Is it a series of lights? Is it a line?
Oh, it would be the brain stuff, and it would be, they have the brain waves that make up the dream, and the idea is I record it from you, and then I play it in me, and I get to feel what you were thinking. I don't know if I want to, John.
I don't.
Yeah.
Like they say, one man's dream is another man's nightmare.
Right.
Yes,
Yeah,
that's
right.
right.
Yeah.
So what is the main reason? Why do they want to know how to do this? I wouldn't want anybody having my dreams.
Yeah, it's a powerful
So what are they looking
Got
for?
key to the personality, I think.
Well, I don't know what these guys are looking at for. Some of them are researching dreams and stuff like this. Certainly in the science fiction stories, a common element of it was it's a product that you can make and sell.
Yeah. And I think it all depends on what your thoughts are on dreams. Like if you follow Carl Jung, he says every single dream is so personal to the individual. And
Right.
what it means to me has nothing to do with what it means to you. So, but now I hear you saying science fiction. So they're like, I don't know. Interesting.
Well, the advantage of science fiction is that it doesn't have to be true.
Right,
You can just make it up.
So moving on to our last story in health, if you want to maintain a healthy weight, should you maybe go on a high protein total diet replacement? Well, what's that all about?
Well, I wanted to have this one because, we've had a lot of different stories about diet, and many of us have the question, what is the right diet to be healthy? And a subset of that has to do with your weight. And we've heard of the low carb diet, but this is a different version of it. And what they are talking about here is, obesity is a big problem around the world, and obesity has tripled in about the last 50 years. And, now there are almost 2 billion adults that are overweight, and about 650 million were obese, very much overweight. So it's a problem. And because it's a problem, they're trying to figure out how to deal with it. There are two approaches that are being used now with some success. One of them is total diet replacements. So these are nutritionally complete formulation of foods that are designed to replace the whole diet for a period of time. I remember in some of my own attempts at dieting, there were these cans of things that you could get. I don't remember what it's called, but your diet would be drinking these cans of good, and it was just as appetizing as it sounds like. So that's the total diet replacement idea, where you just have your meal in a can or something like this. And then another popular weight management strategy is high protein diets. And the high protein diets have been shown to promote weight loss and weight maintenance because they first increase our sense of fullness, and then they actually increase our energy expenditure because it takes more energy to get the nutrition out of protein than it does to get it out of fat or carbohydrates. So the idea is that if you have more protein content, then you've got to work harder to be able to get the nutrition out of it. And so here they were trying to understand, do these diets work? And to get some data, they had people and they divided them into two groups. And one of the groups had the high protein total diet replacement, which consisted of, 35% carbohydrates, 40% protein, and 25% fat. So that really is high protein. The other group was fed a diet that is typical of North American diet patterns, which were 55% carbohydrates, 15% protein, and 30% fat. And what they did, this was not a long-term test. It had them in a metabolic chamber for 32 hours. And again, they were measuring everything and seeing energy expenditure. And then at the end of that, were able to make some judgments. And what they found was that this high protein diet did in fact lead to higher energy expenditure, increased fat oxidation, and a negative fat balance. That means it drove your fat down. And so they say that the result of this study provides further evidence that a calorie is not just a calorie. It really depends on how much energy you have to use to utilize that calorie. And so they are concluding that this high protein diet approach is effective. This was just a short-term test, and so they don't have the data that you would like to have about what about somebody who did it for 6 months or a year or 5 years. Maybe nobody does it for 5 years because they all die in 4. But this is another thing that shows, how we eat and the composition of our food makes a difference.
Any thoughts?
Richard, I've heard a lot about the keto diet, but I'm generally skeptical of diets. Except when a friend of mine said she'd been on it and she lost 20 pounds. My God. And apparently what it is you eat a small amount as you can, I guess, of carbohydrates, grains, and tubers, including sugar and fruit, which has sugar in it. But you can eat meats and dairy, nuts and seeds, and leafy greens. And fat is actually not bad.
Right.
Fat is good.
In the keto diet, what the calories that you don't have with carbohydrates, you really replace them mainly with fat calories.
I guess so, but she lost 20 pounds, which is
I
kind of
know.
impressive.
My wife tried it. She said she loved the diet for what she could eat was bacon. And
Eggs and bacon.
she lost some weight, and she found that her cholesterol went down, which surprised her. Now they are finding the source of cholesterol, they think now, is carbohydrates, not fat. But
interesting. Well, I'm going to try this.
Well, I guess that's it for today. But thanks very much. Thanks, Richard. And we'll see you all next week.
See you next
week.
I won't be here next Tuesday, but
Good to see everyone.
Good to see you.
In 2 weeks, I'll see everybody.
Yeah.
Okay.
Have a nice Thanksgiving if you're celebrating.
Yeah.
Okay.
Yeah, right.
Yeah.
Have a nice Thanksgiving if you're not celebrating.
Yeah.
Stay alive.
Adios. Adios.
Bye.
Bye-bye.
Good to see you, Leslie.
Thanks.